We are in AP Calculus, lesson 4-9, our final lesson of our unit before we start taking our pre-test fix up. What's the word I'm looking for? Self-checks. Thank you. Self-check. First self-check is going to be on Monday. Today's date is November 13th, 2020. Our objective today, Teflon. There it is. All right. So everything comes from Pythagorean Theorem. It's the third of three equations you have to have memorized. You need to know area of a circle, circumference of a circle, and now Pythagorean Theorem. So Pythagorean Theorem, Chris, is? Fiona? Oh, yeah. There it is. Everyone write it down. A squared plus B squared is equal to C squared. And we are going to differentiate this equation with respect to time. Andrea, you're up. What's the derivative of A squared? 2A. A prime. Good. Teflon, derivative of B squared? 2BB prime. And Chris, you do equal to, and then derivative of C squared is? There it is. And notice that you could divide every single term here, or both sides of the equation, by 2. And the more simplified version of this, the one that you don't have to have memorized because it's so easy to take the derivative of, it's AA prime plus BB prime is equal to CC prime. So that's the equation that we're going to be using for the rest of the lesson today. All right, 2 examples, and then we're done. No backside here. Falling ladder problem. Oh my God, I feel like this is on every single AP test. They just love falling ladders. So think about a ladder that's like at a right angle to a wall, and it's either sliding down or someone's pushing it up. Usually it's falling down. So we have a 10-foot ladder, and the top of that 10-foot ladder is sliding down a vertical wall at a constant rate of 12 feet per minute. When the top of the ladder is 6 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So for every single of these triangle problems, all of 4-9, draw a picture. It will help you immensely. So let's go ahead and draw a picture of a ladder. So my ladder is going to look like that. You can do the rungs of the ladder, right? Chunk, 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 chunk. And let's say that's my wall and that's my floor. Essentially, I have a right triangle here. Okay, and then we start labeling things. So remember that each of these sides is really going to have 2 pieces of information. It's not just A, B, and C. We need A prime, B prime, and C prime. So there should be a total of 6 spaces. So I'm just going to randomly say the bottom is A. I could have made the right side A. It doesn't matter. So A prime, we need to find both of those. B prime, we need to find both of those. And C prime, we need to find both of those. So first, it says a 10-foot ladder. What is that, Fiona? You have 1 in 6 chance if you randomly guess. C. All right, so come over here. C is equal to 10. Blah, 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 constant rate. Oh, 12. 12, what is that, Andrea? That is not C prime. C prime would be if the ladder was like collapsing, right? A prime would be if it was horizontal. It's talking about a vertical wall, so it's the up and down direction. B prime is equal to 12. And is it a positive or a negative 12? Negative. Why? Exactly. Perfect. So that 12 means we have a negative 12 over here. I can come over here and grab that, delete it. Okay. 6, Teflon. What does that number mean? Be careful here. The top of the ladder, that means the top here, that is B. B is going to be, you can come back here and say B is equal to 6. And we have other information that is not really there. It gave us one more thing that we're not thinking of, either C prime, A, or A prime. I want to give it to Chris first. Chris, do you see it? What other piece of information is unspoken about this problem that we can list here. It's about C prime. What do we know about C prime? Let me ask a question to help you out to scaffold that question. So C is the length of the ladder. So C prime must be what? What is the interpretation of C prime? Yeah, the rate of the ladder. Like, is it collapsing? Is it extending? So then what do you think C prime is numerically? If the ladder isn't changing. If it's not changing, what's a number that means not changing?
Number that's not changing?
Yeah, what is its rate of change?
Oh,
zero. C prime is 0. Good. All right, then we have these two unknowns, A and A prime. So we can actually solve another one of these right from kind of the get-go. Do you see it, Fiona? Is A prime 12? How do you get A prime is equal to 12? Not necessarily. And in fact, it's definitely not 12, because if it was 12, we'd be done. That's what it's asking for. A prime is the box here. What is A prime? Because it's asking what is the rate of change of the bottom of the ladder. So it's really asking for A prime. So it can't be that easy because we haven't used any calculus yet, really. But we can solve for A. Because if I just think about the three non-calculus terms, if I just have a right triangle here that's 10, 6, and A, I can figure out A. How do we get A, Fiona? There it is. A squared plus 6 squared is equal to 10 squared. Do some math. Help us out, Fiona. And therefore, A squared is equal to, therefore, A is equal to, yep. And technically it's plus or minus 8, but since the domain, it doesn't make sense to have a -8 distance. Yeah, 8. So we can come back here and put that in our problem. A is equal to 8. And what do I do now? And this is just anyone. I have every piece of information except for one. I have one unknown. What do I do? First volunteer. Andre? Yeah, just plug it into that equation that we found up here. So I'll rewrite the equation. A prime plus B prime plus C prime. And we plug in everything. So A is 8. A prime, we'll leave that as A prime because we don't know it. Plus B is 6. B prime is -12. And I don't know why I randomly wrote a plus there. That is very silly. That should have been an equal to sign. So this is equal to C, which is 10 times C prime, which is 0. Then solve. Definitely, you want to do that for us? Minus 72. Is equal to 0. Then you'll add 72, obviously. What's 72 divided by 8? 9. Yeah, there it is. A prime is equal to 9. And now, in an interpretation question for the entire class, 9. Does that mean 9 is going to the right, or is that going to the left? I mean, in our picture, we could have had it flipped, but I guess I should be asking, is it going away from the wall, or is it going towards the wall? Give me a thumbs up if you think it's going towards the wall, thumbs down if you think it's going away from the wall. Is this point down here, the bottom of the ladder, that is A prime, is its rate, is it going away from the wall, towards the wall? And it should be going away from the wall because that's the only way that makes sense if my ladder is going down, if the top is going down. So you want to say 9, and then our units are here, feet per second away from the wall. All right. On to example number 2. The travel problem. All right. I read the last one. Someone else read this one. Who wants to do it? Bless you. Chris, go for it.
Riley and Alex are motorboats located at the center of the lake. Riley begins traveling south at a speed of 21 miles per hour. At the same time, Alex takes off heading east at a speed of 20 miles per hour. At what rate are they separated after 2 hours?
Okay. Let's see if we can draw a picture of this. Again, always try to draw a picture of these right triangle problems. It helps your life. So I'm going to have, I'm going to say that the center of my lake is right about there because I know that I'm going to be going south and east, which means I'm going to be going right and down. I think that's enough room. So let's go ahead and say from that point, I'm going to go right some distance, I don't know, and then I'm going to be going down some distance. So obviously Riley's going down, Alex is going right. Let's go ahead and just randomly assign A, B, and C. So I can say that the distance between them is really the hypotenuse, I suppose. So we can say maybe this dashed line here, this imaginary, well, not imaginary distance, but like if you just kind of like look at the other boat, that distance here, let's call that C. I'm going to call the top A, I guess, and the bottom B, which means I need an A and an A prime, a B prime, and a C prime. Okay. Let's start analyzing this problem then. Begins traveling south at a speed of 21 miles per hour. What is 21, Fiona? Say again? Oh yeah, B prime. So that's going to be 21. Is it positive or is it negative? Okay, positive. At the same time, Alex takes off east, heading at a speed of 20 miles per hour. What does that mean, Andrea? A prime is 20. Positive or negative? Positive. Okay. And again, you should always be thinking positive or negative with every single one of these numbers. Make sure you're interpreting the problem correctly. And we have this weird 2, but I don't know how that fits in here yet. I don't think that fits on our diagram because 2 is a unit of time. Everything here is a measure of distance or speed, not just time. So somehow we're going to incorporate that 2, but not yet. And maybe I should label my start point too. This is where we started, just to make my diagram pretty clear. What are they asking for, Teflon? What's the box? At what rate are they separating after 2 hours? What is our box? Is it B, A, C, C prime? Yeah, C prime. So I'll say come down here. C prime, that's our box. That's the thing it's asking for. Once we get C prime, we're done. Okay. How are we going to do this? I'll let you guys think about it for a few seconds. Yeah, Fiona, what are we going to do? Exactly. Yeah, and just to make sure that people can see it like numerically on paper, if you have 20 miles per 1 hour and you multiply by 2 hours, then the hours and hours will cancel out, chunk, chunk, and you're left with just miles. And how many miles? 20 times 2 miles. So I have a total of 40 miles. So I can come over here and say A is equal to, I don't know why I changed the orange here. A is equal to 40, and therefore B, Andrea, is equal to 42, exactly. You just double the speed. Okay. Well, Teflon, can we solve for, I mean, we have everything solved for except for C and C prime. Obviously, we can't solve for C prime until the very end. How do you think we're going to get C right now then? So ignore all the primes. If you just had A, B, and C, how would you do that? Exactly, yeah, Pythagorean theorem. So we're using our a squared plus b squared is equal to c squared, which means a is 40 squared plus 42 squared is equal to c squared. And then 40 squared, we don't have a calculator on the AP test. Well, for this type of problem, I'm guessing you probably would not have a calculator. You're definitely not going to have one for the fix-ups, the pre-tests, all of that stuff for this unit. How are we going to do 40 squared? And I'll show you some tricks off to the side if you want them. 40 squared is the same thing as 4 times 10 quantity squared, which is the same thing as 4 squared times 10 squared. Whenever you have the squared, it applies to both of the insides, only when they're being multiplied. So 4 squared, Teflon is 16, and 10 squared, 100. Therefore, 40 squared is 1600. So I'll say 1600. How do I do 42 squared? Squared. There's a few different ways of doing 42 squared in terms of the tricks. You could either think of this as, I think the most common way is thinking of 42 squared as 40 plus 2 times 40 plus 2. And 40 times 40 we know is 1600. So we can say in here 1600. And then in this cell, it's 2 times 40, 80. 2 times 40, 80. 2 times 2 is 4. Add all these boxes up, and you get 80 and 80 is 160. So it's going to be 1764. Did I add that up right? You guys give me like a weird look. So 42 squared is 1764. Another way of doing that would be to add the two numbers together, 40 plus 42, which is 82, double it because these numbers are 2 apart, and you get 164, and then you can add 164 to 1600. Have you seen any of these tricks before? No? Should I briefly explain why this trick makes sense? If you want to just speed up your math in the future. All right, backside really quickly here. This is a math trick that might help you in AP Calculus, which is what is the distance between squares? So if I have a squared and b squared, what's the distance between them? I did a subtraction sign because that means distance, right? But you guys know this. A squared minus b squared, that's a formula. That's a difference of squares, which is what? How do I factor that? Times a minus b, which is the equivalent of saying add the squares, or add the square roots, I should say. And then after you do that, then multiply by the distance apart. So for example, we had, we knew 40 squared. We knew 40 squared was 1600. And we're trying to find 42 squared, but we don't know what that is. That was the question mark. So it'd be helpful to know what is the distance between 40 squared and 42 squared. So essentially I'm asking what is 42 squared minus 40 squared. If I knew that distance, I could just add it to 1600 and I'd get the answer. And if you think that this is a lot of work, once you understand this trick, it takes you about 2 seconds to do the trick, and it's really, really fast to find 42 squared. All right, so I add up, again, I add the square root, so I add 42 and 40, and you get 82. and I multiply by the distance apart. How far are 42 and 40? 2. Which means the distance that these two squares are apart, 164. Add 164 to 1,600, so plus 164 to get to your real number, which is 1,764. Cute little math trick, right? And I know, yeah, I have enough time. I just want to verify that you guys know this trick. If I know that 35 squared is 1,225, what is 36 squared? What would you do? What's the trick? Add them. So 35 plus 36. Well, 35 plus 35 is 70, so it must be 71. Then I multiply by distance, 1. Add 71, and you get? 1296. And let's check it out. 36 to the power of 2, 1296. Cute little rule. All right. Well, anyway, coming back to regular AP calculus. 1,764, that's equal to c squared. Add those together really quick. I can do that for you guys. Adding is fun. 3364 is equal to c squared. And you'd have to guess and check. It does come out to a nice number. I made sure it did. Everyone take a guess. What is the square root of 3,364? Andrea, guess. 69, 24, 34, okay. We're guessing square root of 3,364. Fiona, you actually got it. How did you get 58? It's the right answer. Ah, that's smart. Yeah. And then why did you do 58, not 48? Good. Yeah. I love the logic. Yeah. Good job. All right. So that means we have C, which means we're almost all the way there. So C is equal to 58. Then just plug everything in and solve it, right? So we have our default equation, which was A prime plus B prime is equal to C prime. So A is 40, A prime is 20, plus B is 42 times B prime, which is 21, which is equal to C 58 times C prime, which we don't know and we're trying to solve for. Just because we're getting low on time, I will go ahead and simplify this for you. That's 1,682 on the left, still 58, C prime on the right. Divide both sides by 58 and you get 29. So the distance, this yellow dashed line is increasing at a rate of 29 miles per hour. Because that's our speed here is miles per hour, right? So 29 miles per hour. Cool. Question, Chris. Yeah, let me check our fist of 5 for objective first. How well can you do these triangle problems? 4, 4, 4, 4. All right, cool.